In this video, we're going to look at a simple plot, a linear plot in Excel of Hubble's original set of data. So let's get started. So in Hubble, the astronomer, they looked at the distance of stars to the Earth and then used methods to find the velocities. And they made a plot of the velocity versus the distance to see how the speed of an object typically moving away is dependent on the distance. So astronomy has gotten much better since then. But this is the original sort of set of data, and highlight the data, insert chart XY scatter, make a graph. I'm going to do have the highlighted chart design. I'm going to say quick layout. I'm going to go number 9. The x-axis here was that first column, which was the distance, and that was given in a unit called megaparsecs. No, F in distance, okay. And then I don't like the legend, and then the y-axis was velocity in kilometers per second. And then up here, the title, I'm going to say Hubble's original data. Okay, and then I would like to format the trend line. And this is, I'd like this to go through the origin. So I'd like to get rid of that 40 and have a 0. And there's a box here, set the intercept and set it to 0. I could set it to something else, but I want it set to 0. And so then here we have that plot. The r squared is about 0.8. So not bad, but not great. And there is this slope. So the idea is that if the universe is expanding, then things typically are moving away from us. Some things nearby may be moving toward us, but most things will be moving away. And the things that are farther away, we will be moving faster away if something is expanding. So let's just do a little playing around with this result, this slope of this graph. So I did over here in the conversion page, I took this 423.94 I got from the, and that was in the y-axis. This is the slope, so it's a rise over a run. So its units are kilometers per second per megaparsec. So kilometers per second per megaparsec is the units of this 423. Now I'd like to convert it. So I have right now kilometers in the megaparsec as a distance, and so is kilometers a distance. So I'd like to get them both into meters and then have them cancel. So the kilometers are in the numerator here. So I want a conversion of meters over kilometers. And so there are 1,000 meters in a kilometer. So that is this factor here. Then I have megaparsecs in the denominator. So I want to get it first to parsecs. So, and mega is a million, 10 to the 6. But this I want to cancel out. I want in my conversion, I want megaparsec in the numerator and parsec in the denominator. And so there is a millionth of a megaparsec in a parsec. So that was this factor here, and this is Excel's version of scientific notation. So I think I formatted it to put it in the scientific notation, and that's that E. So this is 1 times 10 to the minus 6. that's what that E is. This is 1 times 10 to the 3. I just sort of Googled, found how many, now the parsec is in the denominator. I want to multiply by a factor, something that's sort of equivalent to 1 effectively. So I wanted parsecs over meters, and parsec's a very large distance. And looking it up, I found that it was 3.24 times 10 to the minus 17 of a parsec is a meter. And then I just sort of multiplied those all together. My slope to get the kilometers into meters, to get the megaparsecs into parsecs, get the parsecs into meters, multiply that all out. And then I have this final result. And then those units, I got rid of the kilometers, then I got rid of the, this should have been megaparsec and this parsec, but I got rid of, so this was mega, and this one was parsec. And then finally I got it down to meters per second per meters, and the meters cancel, and it's just, this is reciprocal seconds. And then so if I turn it upside down, 1 on E2, then I get something that is seconds. And then I used convert to convert those seconds into years. So this is the reciprocal of that slope in terms of years. And it is, if we want, let's format cells, number, and let's choose scientific here. Okay, so this is 2.31 times 10 to the 9. So that is billion. So this is, whatever this is, this quantity, this reciprocal of the slope is about 2 billion. And the idea is that this is somehow related to the age of the universe. Okay, now this was the original data, and then can't spell original. The data got much better, even in a sort of, so I found this paper where they talk about sort of the improvements. So here's the sort of data I've got plotted, the original data, and then just sort of, a couple of years later, they had gone sort of, could see things sort of in an order of magnitude larger. So this is going up to 2.5, this is going up to 25. It's about 10 times bigger, this scale. And you can see it sort of lining up a little bit better as we get more data, so that as we learn more, this initial idea of this linear relationship sort of got better. And then they go on and do, as they find, go out farther and farther as astronomy improved. This sort of lining up of the data gets even better. And then some slight curves in here. And so all I want to do is sort of play around with Excel. And so we played around with Excel. We saw how to set the intercept to 0. We know that the R squared is giving us an idea how good a fit it is. So if we had this other data, we could see if those fits were improving, if that R squared was getting closer to 1. And then we also played with the conversion here to sort of get it into some idea of, that the slope was a reciprocal time. What was that reciprocal time in a basic unit like seconds? And then take the reciprocal of it, and then also get that into years. They tend to report the, although the second is more the scientifically basic unit, they do tend to report the age of the universe in years and billions of years. So this isn't the age of the universe, but it is like of the order of the magnitude of the universe. So then there may be one, we have to get better data than this original Hubble, which you can see in this paper, but also then it doesn't necessarily mean that there may be some other factors, that this just reciprocal of the slope may not just be the age. There may be some multiplicative factor in there between the age and this particular slope, this particular set of data being plotted. Okay, that's what I wanted to show. Thanks for your attention.